So here in Houdini, we'll import all our models that we exported from Maya. So let's drop a geometry node, and we'll call this import models. So this like a geometry a node is like a container that can contain anything from SOP geometry, SOP as in polygons and whatnot, and all kinds of SOP stuff. And even it can also contain dynamics, fluids, all those containers. I mean dynamics stuff as well. So you can think of it as like a layer in Maya. So when you go in there and you see everything's laid out there. So let's create a file node to import our obj object. And so let's go over the geometry file and look for the objs. So I'll look for where I've saved that, and G. Or was it my temp directory? Yeah, it's in my temp directory. Desktop, temp, pillar and slabs, and we have merge pillars. So we'll bring in our pillars first. Okay, there it is. Yeah, okay. And turn on wireframe. I think the scale is fine, but I think it's, I mean, if you drop down a box right now, so that box is 1 meter by 1 meter by 1 meter. So just to check the scale, I mean, obviously if you look at the pillar, it says it's around 1 meter, around 1.2 meters, but in real life that's not true, right? In real life the pillars or the ceiling height should be around 2-3 meters. But with Houdini, I think to get good results, scale is important, because you may never know, you might even go ahead and do the simulation for smokes, particles, etc. So I think this default size that I brought in from Maya is fine. So let's delete the box, go inside, and so if you middle click this guy, we'll see there are 224 primitive and pillars, but I mean polygons. And that's the faces. We have 1 2 3 4, so 4 8 12 4 3 12 16 pillars. So let's drop down, let's make another file node, and this time we'll bring in the slabs. So that's the slabs, and to view it together, let's merge it. So that's the file. It might be a little big, but let's just say that this is fine, and we'll go ahead and since the scale is fine, I'll drop down a null. First let's call this pillars, and this will be slabs. And in my custom self, I got this script from my website. I forgot where I got it from. It's just a simple Python script that when you select a node and create this, it makes a null with the out text. So if I select these two and create null, it makes null for both of them and puts in the name for these guys. So it's really handy tool for large projects. I mean, if you want, I can maybe put it up in a description. If I remember the guy's name who made this, I would really I would give him the credit, but I really forgot where I got it from. But thanks anyway, whoever did this. So we have two of them out, and we'll drop down on object merge. Object merge is like a container that we can copy paste it in another geometry SOP. I call it SOP. So we can just drag this out pillar and put it in object 1. So we have a pillar there, and make another object merge, and we'll drop the slab here, and let's just control X for cut and make it geometry again, and we'll call this Voronoi fractures. So here is all the fracturing stuff will happen here. So we'll copy and paste the stuff from the import model geometry to here. So I got it here. So let's start fracturing this guy. Before that, let me just see what I can do. How like I'm just right now I'm just thinking how to break this building. I mean, okay, from the video that I've seen in Vimeo, it was something like it was like this guy falls down, and these guys in turn causes a chain reaction that breaks these guys and these guys and these guys. So what I think, I can make a sphere and just give some mass but no velocity, and just drop it on top of this first slab, so that will cause these guys to break, and in turn create some impacts, and it breaks the other fractured objects. In a way, it causes a total collapse of the building. So let's do that. First, let me fracture. Fracture as in we'll use Voronoi fracture to fracture. Pre-fracture these pillars. Okay. So we have. We'll do a connectivity for that. Yeah, that's fine. We'll define a class so that we can do a for each operation. That's a primitive class, and so we have all the classes here. By the way, I'm not really I'm also learning a lot of Houdini these days, so I'm not a pro in these, like, not really. I'm a self-taught artist, so whatever I do is what I've learned across the time that I've been learning Houdini from different websites, any kind of source materials, Houdini masterclass, and some premium trainings. So what I do here might be similar to some of those, but what I want you to grab is the idea of, like, the basic idea of how fracturing happens in Houdini. Fracturing as in destruction stuff. So let's drop for each loop. For each loop is something that loops around and does something that's, I think it's a bit more suited for programming, but as an artist I use it for what I think is working. So for, we'll take attribute value. Attribute value was class, remember we assigned it, and we type class name, and then we go in and it looks for one guy. So whatever I do with this one guy will be looped over to all the other pillars. So over here we can drop down a scatter node, and maybe that's too much. 74. Let's do even much less. 21. Do a Voronoi fracture. So that fractures a geometry. We can control the amount of fracturing with the scatter points. So if it's 10, it's much less. Let's say I think I might even want 50. 50 is fine. Or even better, I can make it lower count, like 11, and then we can also use for my fracture points. If you really want to know what a node does, you just go select the node and go over here and see, click for help. That's also really good. And then we have to add the geometry. That's from the for each loop, and we also use this scatter. Reduce the impact radius, like so. Visualize points per area, 20. I mean, you can see a few points there, those red and yellow. This is just to make our fracture a little bit more beautiful, I think. Beautiful. I think I'll use another scatter node instead of that. So let's scatter 50 points. Scale the impact radius. Ooh. And then we can merge it. Yep. So we can visualize this by an exploded view node. Okay, it's cooking. Oh. Okay, what's wrong? Something's going on here. Let me just check again. Yeah, so I checked again. I just had to go out of the node and come back in again. It's just a viewer thingy. So we have our stuff fractured. If I disable this, and so that's cooking again. So you see everything is fractured here. So if I drop down an exploded view, you see everything is fractured. All the pillars. So that's our pillars. Now let's do the same for let's just copy or just make another null, not null, I mean the connectivity SOP. Same thing here, that's primitive, and drop down a for each subnet attribute value class. Now for the slab, we'll use a Voronoi fracture points, because I feel this gives me much good of a look for the fracture. Phew. Come on, come on, come on. Let's make it 40. Ah, even before that, I'll just put a ISO offset node so that fills our geometry, so we can scatter the point inside the slab as well. Let's make it 50, and then scatter it. Whoa, that's a lot. So 95 points. And one. Just visualize points and increase the volume. So this gives us some points from where the Voronoi fracture will reference the fracture points. So let's drop down a Voronoi fracture. Take the geometry and the points. So there is our fracture. So if I go back now, since I've done this to one of the slab, and since it's a for each loop, it will do it on all the slab, which I'll show you. See, so all of them have the fracture applied to it. You can also randomize the fracture pattern, but for our purpose, I think we are okay. So drop an exploded view to visualize. See, everything is fractured. Now we can drop down a null. So out, we'll call this, yeah, that's out for each, and then we'll do an object merge where we'll drop the same thing we did in the import model geometry node. We'll call merged pillar fracture. Same for this guy, but replace this with the slab, and we'll call this merged slab fracture and just cut it and make another geometry. We'll call this constraints and simulations. So if you look at it, it's first layer we imported the models, and the second layer we did the fracturing and all. Now in the third layer we are gonna do all kinds of constraints and simulation. So first we'll make a glue constraint to hold. Even before that, let me just demonstrate something. So right now everything is all of them is just a fracture, like pre-fractured fragments, and if we put it into a bullet simulation, it's not gonna hold and it's just gonna fall down because there is no constraint. So the way we're gonna do is the pillar, let me just put it, the pillar will have a constraint, all the pillars. Let me finish it up. So the pillars are gonna have constraint, so they will stand, they will hold the ground, and then we'll make a glue constraint for the slabs. So the slabs will have a different strength, a different glue strength. Normally like if someone who's new, what they will do is they will make a glue constraint for all. So the pillar, the slabs, all of them, they're gonna have a single glue. But that's not good. Like in real life, the pillars will have like a different strength than the slab. So but the way we are doing is we have glue for the pillars and we have glue for the slabs, and then we're gonna have a glue for all. So what I mean is in that way the pillars will have glue, let's say of like 90%. The slab will have like 60%, and the whole of the glue is gonna have just 1%, just to hold them together. They're just sticking to each other so that they don't fall. Because if I have glue for if I don't have that whole glue, then what will happen is, since pillar are glued and the slabs are glued, but when I put it into simulation, they're just gonna fall down. So with that in mind, we'll do that in the next chapter, where we will create a constraint for the pillar and the the slab. So see you in the next video. Thank you.